Hello everyone, welcome back to our Geography NCERT series. Today's video is part 2 of Chapter 1 where we'll explore the solar system in detail. This topic is important from a general knowledge perspective, but it's not strictly a part of Chapter 1. So if you want to focus only on Chapter 1, you can limit yourself to the sections on the Sun, Earth and Moon. But if you want a stronger conceptual foundation, which will help you later when you study geography and science and technology, I'd highly recommend going through this entire video. Let's get started. Our solar system consists of the Sun, our star, 8 planets, that is Mercury to Neptune, dwarf planets like Pluto, Eris, and Ceres, natural satellites like the Moon, and minor bodies like asteroids, meteoroids, comets, and debris. Beyond Neptune, we have the Kuiper Belt that contains icy objects. And at the edge of our solar system, we have the heliopause and the Oort cloud. The Oort cloud is the outermost shell of icy bodies and the birthplace of long period comets. Like we saw earlier, the solar system consists of the Sun, planets, also dwarf planets, satellites, asteroids, meteoroids, comets, and debris. The word solar comes from the word Sol, which is the Roman sun god. Solar means related to the sun, and therefore the solar system is the sun's family. This system formed about 4.6 billion years ago from a giant cloud of gas and dust. Gravity pulled everything together, with the sun forming at its center. Now let's look at our solar system in detail. Let's start with the sun. The sun is a yellow dwarf star that sits at the center of the solar system. It is a huge ball of hot gases, mainly 98% of hydrogen and helium, and is the ultimate source of heat and light for all planets. It rotates in a counterclockwise direction and holds the solar system together due to its strong gravitational pull. As we've seen earlier, the closest star to the Sun is Proxima Centauri. The Sun is around 150 million kilometers away from the Earth. This distance is called an astronomical unit, or AU. Since the distances in the solar system are too large for kilometers and too small for light years, we use astronomical units for measurement. For example, while the Earth is 1 astronomical unit away from the Sun, Neptune is around 30 astronomical units away. This is simpler than saying Neptune is 4.5 billion kilometers from the Sun. Now that we have seen what an astronomical unit is, let's see what a light year is. Light in vacuum travels at approximately 300,000 kilometers per second. This is the fastest possible speed in the universe. Even though light is extremely fast, it still takes time to travel vast distances. The sun's light takes about 8 minutes to reach the Earth. We know that the sun is 150 million kilometers away from the Earth. If you divide this by 300,000, that is the speed of light, and multiply it by 60, because 60 seconds makes a minute, we will get 8.33 minutes. Similarly, the moon's light takes 1.3 seconds to reach our Earth, as the moon is around 384,000 kilometers away from the Earth. This means that when we see the sun or the moon, we are actually seeing them in the past. That is, the sun as it was 8 minutes ago and the moon as it was 1.3 seconds ago. Coming to a light year is the distance light travels in 1 year. 1 light year is around 9 trillion kilometers. It is used to measure vast distances in space. For example, Proxima Centauri is around 4.2 light years away. This means the light from Proxima Centauri takes about 4.2 years to reach us. The farther the object is, the further into the past we are looking when we see it. So to recap, the Sun is a yellow dwarf star. 98% of the Sun is made of hydrogen and helium. The Sun is 150 million kilometers from the Earth. This is known as an astronomical unit. And the closest star to the Sun is Proxima Centauri. We also saw the speed of light. Light travels at a speed of 300,000 kilometers per second. The Sun's light takes 8.33 minutes to reach the Earth, while the Moon's light takes around 1.3 seconds to reach the Earth. 1 light year is around 9 trillion kilometers. Now, let's take a look at the Moon. The Moon is Earth's only natural satellite and the fifth largest satellite in the solar system. It is 384,400 kilometers away from the Earth and is about 1/4 the size of Earth's diameter. Despite being much smaller than the Sun, it appears as large as our Sun in the sky because it is much closer to us than the Sun. Let's see the concept of tidal locking. The Moon is tidally locked to the Earth. This means the time it takes for one rotation of the Moon around its axis is equal to the time it takes for one revolution of the Moon around the Earth. Both the rotation and the revolution takes 27.3 days. In the next video, the Moon on the right is just a zoomed in version of the Moon on the left. The one on the right depicts the rotation, while the one on the left depicts the revolution. You will notice that the Moon completes one rotation or 360 degrees around its axis in the same time that it completes one revolution or 360 degrees around the Earth. Meanwhile, you'll notice that the Earth rotates 27 times on its axis in the same period, that is approximately 27 days. Because of tidal locking, one side of the Moon, called the near side, always faces the Earth, while the other side, or the far side, or sometimes called the dark side, always remains hidden from the Earth's view. Though the far side is called the dark side, it is not actually dark. It receives sunlight just like the near side. The term dark refers to the fact that it remained unseen and unknown to humans for most of history. In the next video, notice how the side with the eyes always faces the Earth, while the other side with the dot never faces the Earth. It's almost as if an imaginary string connects the Earth and the Moon, with the Earth spinning the Moon around itself, just like a ball tied to a string is swung in a circle. So we saw that the Moon is tidally locked with the Earth, and both its rotation and revolution takes 27.3 days. Now let's explore the lunar phases, which take 29.5 days. The phases of the Moon occur due to the changing positions of the Sun, the Moon, and the Earth as the Moon orbits the Earth. The portion of the Moon illuminated by the Sun keeps changing as seen from Earth, creating different phases. One entire phase takes 29.5 days to complete. First, let's see the new moon and the full moon. Here, the Sun, the Moon, and the Earth are in a relatively straight line. During the new moon, the Moon is positioned in between the Earth and the Sun. The side of the Moon facing the Earth is not illuminated, making the Moon invisible in the sky. The new moon rises and sets with the Sun, so it's mostly in the sky during the day. Whereas it is a full moon when the Earth is in between the Sun and the Moon. This allows the entire near side of the moon to be fully illuminated by the sun. The full moon rises at sunset while it sets at sunrise. This is when a lunar eclipse can occur, but only if the moon crosses the Earth's shadow. The new moon is called Amavasya and the full moon is called Purnima. New moon to full moon or full moon to new moon takes 14 days. This is called a fortnight. A fortnight comes from 14 nights and generally it means 14 days. If the Earth, Sun, and Moon are in a straight line during new moon and full moon, why don't we see solar eclipses or lunar eclipses every month? The answer lies in the moon's orbital plane. If the Sun, the Moon, and the Earth were perfectly aligned every full moon and new moon, we would get a lunar eclipse every full moon and a solar eclipse every new moon. But this doesn't happen because the moon's orbit is tilted approximately 5 degrees relative to the Earth's orbit around the sun, that's called the ecliptic plane. The ecliptic plane is an imaginary plane containing the Earth's orbit around the sun. In simple terms, it represents the path the Earth follows in its orbit around the sun. Because of this tilt, the moon is usually either slightly above or slightly below the ecliptic plane during most new moons and full moons. Eclipses occur only when the alignment is just right, and this happens only a few times a year and not every month. Now let's see the first quarter and the last quarter. Here, the sun, the moon, and the earth form a right angle, that is 90 degrees. The first quarter occurs when the moon moves 90 degrees in its orbit after a new moon. In this phase, we see only half the moon illuminated. The last quarter occurs when the moon moves 90 degrees in its orbit after a full moon. Here, the other half of the moon is illuminated. Then we have waxing and waning phases. Waxing is when the illuminated portion increases, while waning is when the illuminated portion decreases. So now we have seen that the phases take 29.5 days, but the rotation and revolution take only 27.3 days. Let's see why the phases take an extra 2.2 days. The extra 2.2 days in the lunar phase cycle occur because as the moon revolves around the Earth is also moving forward in its orbit around the sun. The moon completes 360 degrees around the Earth in 27.3 days relative to distant stars, which is called a sidereal month. We saw in the previous slides that for a new moon to occur, the sun, moon, and earth have to be in a relatively straight line. However, after 27.3 days, the moon is not yet in a straight line with the sun and earth for the next new moon because the earth has moved 30 degrees in its orbit around the sun. To realign with the sun-earth system and complete the lunar phase cycle, the moon must travel an extra 30 degrees, making it a total of 390 degrees. This takes an additional 2.2 days, making the total duration 29.5 days, which is called a synodic month. The synodic month is the time from one new moon to the next new moon, or from one full moon to the next full moon. So in short, a sidereal month takes 27.3 days and is when the moon moves 360 degrees around the earth relative to distant stars, while a synodic month takes 29.5 days and is when the moon completes one full lunar phase cycle. The moon's surface has mountains, plains, and craters. It has a very thin atmosphere called an exosphere, has no water, though Chandrayaan found traces of water, and has extreme temperatures, making it inhospitable for life. Neil Armstrong and Buzz Aldrin were the first humans to land on the moon in 1969 through NASA's Apollo 11 mission. They were accompanied by Michael Collins, who was their pilot. So to recap, The Moon is 384,400 kilometers away from the Earth. It is one-fourth the diameter of the Earth. It is tidally locked with the Earth, and its rotation and revolution take 27.3 days, known as a sidereal month. The phases of the Moon take 29.5 days, known as a synodic month. And Neil Armstrong and Buzz Aldrin were the first humans to land on the Moon in 1969 through the Apollo 11 mission. Now let's take a look at the planets of our solar system. The solar system has 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These planets can be divided into two groups based on their composition and location. The inner planets or the terrestrial planets are Mercury, Venus, Earth, and Mars, or the first 4 planets of the solar system, while the outer or the Jovian planets are Jupiter, Saturn, Uranus, and Neptune. These are called the inner planets because they lie closer to the Sun, between the Sun and the asteroid belt. While these are called the outer planets as they are located beyond the asteroid belt, farther from the Sun. The inner planets are also called terrestrial planets, meaning Earth-like, because they have rocky and metallic surfaces with high densities. On the other hand, the outer planets are called Jovian, meaning Jupiter-like, or sometimes called gas giants, as they are huge planets made mostly of gases with no solid surface. Though the Jovian planets are generally called gas giants, sometimes they are further divided into two groups. Jupiter and Saturn are called gas giants as they are primarily composed of hydrogen and helium. Uranus and Neptune are called ice giants because they also contain more water, ammonia, and methane ice, distinguishing them from Jupiter and Saturn. Let's see the differences between the inner and outer planets. When it comes to size, the inner planets are smaller, while the outer are much larger. When it comes to their surface, the inner planets are rocky and metallic with solid surfaces, while the outer planets do not have solid surfaces and are mainly made up of gases and ices. Coming to their moons, the inner planets have few or no moons, while the outer planets have many moons, with Saturn having the highest number of moons. Talking about rings, the inner planets have no ring system, while all the outer planets have rings. You can see here that all the outer planets, Jupiter, Saturn, Uranus, and Neptune, have rings. These rings are made up of rock, ice, and dust. Coming to their density, the inner planets are denser than the outer planets. Let's go over the direction of rotation and revolution of the planets. The Sun rotates in a counterclockwise direction when viewed from above the North Pole. All the planets revolve counterclockwise around the Sun. When it comes to rotation, most planets rotate counterclockwise, that is, the same direction as their revolution around the Sun. Here, Venus and Uranus are exceptions. They rotate clockwise around their axis, which is called retrograde rotation. Another interesting fact about Uranus is that it rotates on its side because its axial tilt is about 98 degrees. Due to this, it appears to roll along its orbit rather than spin upright like the other planets. Now let's see the Sun's closest neighbor, Mercury. Mercury is the smallest planet in the solar system, even smaller than some moons like Jupiter's Ganymede and Saturn's Titan. It is the closest planet to the Sun, but not the hottest. The hottest planet in the solar system is Venus. Mercury doesn't have a regular atmosphere and instead has a thin exosphere, so it cannot retain heat, leading to extreme temperature variations. Its daytime temperatures can reach as high as 427 degrees Celsius, while its nighttime temperatures can reach as low as minus 173 degrees Celsius. Therefore, it has the largest diurnal temperature variation in the entire solar system. It also has the fastest orbital period, taking only 88 days to complete one orbit around the Sun. Its rotation, however, takes 59 days, so one Mercury day lasts 59 days. So, to sum up, Mercury is the smallest planet in the solar system. It is the closest planet to the Sun. It is not the hottest planet. Mercury doesn't have a regular atmosphere and instead has a thin exosphere, and its rotation takes 59 days, while its revolution around the Sun takes 88 days. Venus is the second planet from the Sun, and it's often called Earth's twin. This is because it is similar in size, structure, and composition to the Earth. It is the hottest planet in the solar system. This is because its thick atmosphere traps heat due to the greenhouse effect. Its surface temperatures can reach as high as 475 degrees Celsius, hot enough to melt lead. It is the brightest planet in the night sky and the third brightest object visible from Earth after the Sun and the Moon. As seen earlier, Venus has a retrograde rotation, that is, it rotates clockwise unlike most planets. A day on Venus is longer than a year on Venus. One day takes 243 days, while 1 year takes only 225 days. To sum it up, Venus is the hottest planet in the solar system. This is due to its dense atmosphere. It is called Earth's twin due to its similar size, structure, and composition. It has a retrograde rotation, that is, it rotates clockwise around its axis, and it is the brightest planet in the night sky and the third brightest object in the sky. The Earth is called the blue planet and is a unique home for life. The Earth is the third planet from the Sun and is the fifth largest planet in the solar system. It is the only planet known to support life. This is because it has water and air that are essential for life. It also has life supporting gases like oxygen and nitrogen. Additionally, its moderate temperatures ensure that it is neither too hot like Venus nor too cold like Mars. The Earth is situated in a zone called the Goldilocks zone. The Goldilocks zone is the perfect distance from the Sun for liquid water to exist. Here it is neither too hot nor too cold, but the temperature is just right for liquid water to exist. This is inspired by the fairy tale Goldilocks and the Three Bears. The Earth is called the blue planet because 2/3 of the Earth's surface is covered by water. Oceans reflect sunlight, making the Earth appear blue from space. The shape of the Earth is an oblate spheroid. Here it is flatter at the poles while it bulges at the equator due to rotation. This shape of the Earth is also called a geoid. Geoid means Earth-like shape. This image is a true representation of the Earth's surface. Here you can see that it's bulging at the equator while it is flatter at the poles. To sum up, the Earth is the third planet from the Sun. It is the fifth largest planet in the solar system. Its shape is called a geoid and it is an oblate spheroid. It's called a blue planet because 2/3 of its surface is covered by water, and it is located in the Goldilocks zone where liquid water exists. Next we have Mars, the red planet. Mars is the fourth planet from the Sun. It has a reddish appearance because its surface is rich in iron oxide or rust. It has a thin atmosphere and extreme weather like intense dust storms that can last for weeks. On its surface, it has impact craters, valleys, mountains, and deserts. Mars has the largest volcano in the solar system called Olympus Mons. It also has one of the largest canyons in the solar system called Valles Marineris. we saw that the inner planets have few or no moons. Mercury and Venus have no moons, while Earth has one and Mars has two, Phobos and Deimos. To sum up, Mars is called the red planet as its surface is rich in iron oxide or rust. Mars has two moons, Phobos and Deimos. Mars has a thin atmosphere and intense dust storms that can last for weeks. Mars also has the largest volcano in the solar system, Olympus Mons, and one of the largest canyons in the solar system, Valles Marineris. Then comes the asteroid belt, which is situated between Mars and Jupiter. It is a circular chain of rocky and metallic bodies orbiting the Sun. Ceres is the largest object in this belt and classified as a dwarf planet. We also saw the Kuiper Belt, which is beyond Neptune's orbit. It is similar to the asteroid belt but made up of icy objects. It contains dwarf planets like Pluto, Haumea, and Makemake. We also saw the Oort cloud, which is at the edge of the solar system. It is a giant spherical shell of icy bodies surrounding the solar system. It is also thought to be the source of long period comets like the Halley's or Halley's comet. To sum up, the asteroid belt is between Mars and Jupiter. It's made up of rocky and metallic bodies. Ceres is the largest object in the asteroid belt and a dwarf planet. We also saw the Kuiper belt beyond Neptune's orbit that contains icy bodies. And we saw the Oort cloud at the edge of the solar system, which is a giant shell of icy bodies that encircles the solar system. Next is Jupiter, the giant among giants. It is the fifth planet from the Sun and the largest in the solar system. It is a gas giant just like Saturn and has no solid surface and composed mostly of gas and liquid swirling in complex patterns. It has an interesting feature called the Great Red Spot. The Great Red Spot is a massive storm on Jupiter that's larger than the Earth and has been raging for centuries. Jupiter has 95 moons, including 4 large moons, Io, Europa, Ganymede, and Callisto. These 4 moons are called Galilean moons, named after Italian astronomer Galileo Galilei, who first observed them in 1610. Ganymede is the largest moon in the solar system. Jupiter is also the fastest rotating planet in the solar system and rotates around its axis in only 9.9 hours. So to sum up, Jupiter is the biggest planet in the solar system. It is a gas giant just like Saturn. It has the fastest rotation time or the shortest day in the solar system, that is 9.9 hours. It has a huge storm called the Great Red Spot, and it has 95 moons in total, including 4 large moons that are called Galilean moons. Next is Saturn, the ringed giant. Saturn is the sixth planet from the Sun and the second largest planet in the solar system. Like Jupiter, it is a gas giant with no solid surface. It is the least dense planet in the solar system, even lighter than water, and theoretically, it would float in a giant water body. It has a spectacular ring system, having the most iconic rings in the solar system. These are made up of billions of dust, rock, and icy particles. Saturn has the most moons in the solar system. It has a total of 274 moons. Earlier, it had 146 recognized moons, but recently, 128 additional moons have been discovered, taking its total number to 274. Its moon Titan is the second largest moon in the solar system after Ganymede and is larger than Mercury. So, Saturn is the second biggest planet in the solar system and it is a gas giant just like Jupiter. It has a spectacular ring system. Its density is less than water and it has the most moons in the solar system, 274 in total, and has the second largest moon in the solar system, Titan. Next is Uranus, the tilted ice giant. Uranus is the seventh planet from the Sun and is an ice giant just like Neptune. It also has a hydrogen and helium atmosphere like Jupiter and Saturn, but has a higher proportion of ices which include water, ammonia, and methane. Though Neptune is the farthest planet from the Sun, Uranus is actually the coldest planet in the solar system. It has the coldest recorded temperature of -224 degrees Celsius. Like we saw earlier, Uranus also has a retrograde rotation like Venus and it spins clockwise around its axis. Uranus has a unique axial tilt and it rotates almost on its side. The axial tilt is about 98 degrees. This causes extreme seasonal variations, with each pole getting 42 years of continuous sunlight followed by 42 years of continuous darkness. Uranus has 27 moons, the largest being Titania and Oberon. To sum up, Uranus is one of the outer or Jovian planets. It is an ice giant along with Neptune. It is the coldest planet of the solar system. It spins sideways, its axial tilt is around 98 degrees, and it has a retrograde rotation. The last planet is Neptune, the windy ice giant. Neptune is the eighth and farthest planet from the Sun. Just like Uranus, it is classified as an ice giant. Its deep blue color is due to methane, which absorbs red light. Though it is the farthest planet from the solar system, it is not the coldest planet. This is because of its internal heat, which makes it slightly warmer than Uranus. Neptune has the fastest winds in the solar system, with winds reaching up to 2100 km per hour. An interesting feature on Neptune is the Great Dark Spot. The Great Dark Spot is a massive storm system similar to Jupiter's Great Red Spot. Neptune has 14 known moons, with Triton being the largest. Neptune takes 164 years to complete one orbit around the Sun. So Neptune is a Jovian or outer planet. It is an ice giant just like Uranus. It is the outermost planet but is not the coldest planet. It has the strongest winds in the solar system, some going as fast as 2100 km per hour. And it has a great dark spot, which is a storm similar to Jupiter's Great Red Spot. That brings us to the end of Chapter 1. In the next video, we'll move on to Chapter 2, Globe, Latitudes and Longitudes. If you found this helpful, don't forget to like and share this video and subscribe to Clinch It for more such content. Thanks for watching and I'll see you in the next one.